Hi, the third topic of this lecture is the assignment problem. The assignment problem refers to the class of linear problem that involves determining the most efficient assignment of people to projects, salespeople to territories, auditors to companies for audits, contracts to bidders, jobs to machines, heavy equipment to construction jobs, and so on. The objective is often to minimize total cost or total time of performing the tasks at hand. One important characteristic of assignment problem is that only one job or worker is assigned to one machine or project. Here is the network diagram for assignment problem. As you can see, there are three people, Adams, Brown, and Cooper, and we have also three projects, project 1 and 2 and 3. And as you can see, Adams has different skill sets and talents, and as a result, he has a different cost structure for each project. Project 1, $11, and Project 2, $14, Project 3, $6. The same goes Brown and Cooper. One interesting characteristic here, you see that the supply is only one and demand is only one. In other words, one person, there's only one Adams, there are not two, and there's only one person who can take project one, right? So that's a one-to-one relationship. One-to-many or many-to-one or many-to-many relationships are not allowed here in this case. Let's say, project one is fixing radio, and project two is toaster oven, and project three is coffee table. And Adams and Brown and Cooper might have different, expertise in these repairs, and they may incur different costs as a result. Now this network diagram we saw, then let's formulate the answers together. So first let us define variables. We have xij and the constraints are quite straightforward. Let's say xij equals 1 if person I is assigned to project J. If the person is not assigned to project J, then it's 0. And we have only three people, 1, 2, 3, Adams and Brown and Cooper, and three project 1 and 2 and 3. To formulate the objectives, we have to apply this cost structure to our variables, and $11 for Adams to project 1, $14 from Adams to project 2, $6 from Adams to project 3. The same goes to the others. So for example, $8 for Brown to project 1 and 2 and 3 and so forth. We have only very straightforward supply and demand constraints here. Supply is that there's only one Adams, right? So Adam can go either project 1, 2, and 3, but the constraint is 1. So 1 to 1, x1, 2, and 1, 3 can happen, but it has to be constrained to 1, right? So we are just expressing it in a mathematical format. The same with Brown. It's a 2, x2 is a Brown, and then the destination changes to project 1 and 2 and 3, but it has to be 1. So these first three are a supply constraint, and then the next three are demand constraints. So project 1, it is demanded by project Adams and then Brown and Cooper. So the destination is fixed as 1, and Adams and Brown and Cooper are coming there, but the demand is only 1. There are not more than one demand for that. And you express that here, and then you are done with constraints setup. If you do that, now we are ready to go to Excel solver and solve it, and we find that the best option is Adams take project 3 and Brown project 2 and Cooper project 1, and the total cost in that case will be $25. And let's solve it together using Excel solver.